we're going to talk vision and futures. My name, as Tiffany said, Mark Simos. I go by lead cybersecurity architect, director of strategy, bunch of different titles. I don't really get too picky about it, honestly. But what we're going to be talking about today is really about where we see this space evolving, how we're thinking about it, and some hints in the future direction, some of which have already been dropped throughout the course of some of these other ones. But I'll be a little bit stronger in some areas to just show you the direction that we're taking in our ambitions in this space. So first and foremost, as we think about this space all up, IoT and OT risk is business risk, period. IT risk is definitely right there in that same realm, but IoT and OT tends to be a little bit more specific and a little bit more concrete in terms of the risks to an organization, because it does take the cyber world or the technology world into the physical space. So we do see a lot of risks that organizations face and have dealt with consequences of in the financial space, shutting down factories and the like. I mean, it's really easy in most cases to measure the impact of this, so we do see that as a big deal. Probably not new to many of the folks in this session. IP theft, not necessarily as prevalent or as top of concern as it is in the IT space. IT spaces tend to be a lot more focused on that sort of confidentiality assurance, but it is still definitely a very real risk that has been realized in a number of places in the OT and IoT space as well. And then this one is fairly unique to the IoT and the OT space, which is safety. Life safety impacts and risks are very, very real in this space, because just about anything that is doing anything interesting today in the physical space is probably controlled by a computer, OT. So don't want to belabor this because I know y'all are fairly familiar with it, but this is helping kind of frame the way we think about this space and the way we think about what problems we have to solve at the high level. Putting this into a vision of, okay, what are we trying to do here in this space from a Microsoft perspective? Ultimately, like everything else, it's about empowering people and organizations, but we're trying to build strong, reliable, resilient security wherever physical and cyber worlds meet. So that's really what we're trying to do at the high level. And the way that we're approaching this, and you'll start to see this evolve over the course of the presentation and coming years, of course, months and years, actually, not taking too long for some of these things. First and foremost, brownfield. We've talked a lot about that. Essentially, fix what you've got, secure what you've got to the best of your ability, because we know there's a lot of constraints. We'll be talking about that in just a moment, a lot more depth. But that is we got to start with what we have and protect it as best we can, acknowledging that there is an intense set of constraints in this world. And then greenfield. We don't want to be continuing to ship problems. We don't want to be shipping new capabilities that don't meet our current best practices and standards. And so that is another prong of the strategy on how we're thinking about this, which is we want to catalyze that a secure device ecosystem so we can have sustainably resilient IoT and OT environments. We want to get ourselves out of growing this pain, especially considering the scale and scope of how fast IoT is growing in presence, numbers, and really any measure. And so taking a little bit of a stoic philosophy here, the obstacle is the way. In this particular space, there is definitely an external problem. There's definitely the attackers that are doing their thing, but some of the biggest challenges, the biggest problems to solve, the most interesting ones, and from a partner and integrator perspective, business opportunities come from focusing on sort of the inherent constraints and challenges within the customer space. So one of the biggest first things that we know we need to solve is the people problem. OT and security culturally, professional identity-wise, see themselves as different teams with different missions. They have different language, different ways of looking at things. And so mutual education to help build that single sort of, hey, this is all one security thing. And we have to look at this like the attackers do, which is it's one environment because they're going to navigate it in that way, requires getting folks to be comfortable with each other's worlds. OT teams need to understand security. Security teams need to understand the world of OT. So we see that as being one of the key foundational elements to address, is helping bring those folks together and understand the problems through each other's lenses. Second one, got to change the mindset. We have seen a whole lot of firewall and forget type of thinking, which is, oh, we've got it isolated with the firewall. That's all fine and good until the vendor brings CryptoLocker in on their maintenance laptop and takes down the entire factory. True story, can't go into the details, Chatham House rules, but we see this challenge that, oh, we have this problem solved because we cordoned it off. Yes, that's a very important control, that's a useful control, but we need to see people thinking much more people process tech to be able to solve this so that you're addressing all those things on how the business actually works and operates every day. And so that's a key thing that needs to be addressed in this space as well. And I've got some guidance on the way we're thinking about this a little bit later. And then embracing the constraints. Like, we have to recognize and be completely open and honest with the things that are making our lives more difficult. So fragility. There's, if you get too active in this, going back to Matt's example, there is, especially in the OT environments, a little bit less so in the IT environments, simply doing a scan could crash and take down something that, is, high up in the air and many miles away from the nearest technician that's able to do the reboot. So there's a fragility problem. There's a distributed ownership problem. Sometimes these things are owned and controlled by a plant manager, right? Sometimes they're centrally controlled. So you have a lot of different sort of politics elements that usually come into play, a lot of unmanaged and, quite frankly, unmanageable devices, a lot of regulated use cases that we can't touch this because this exact configuration, minus the patches, which is where it is actually, out there. So we have that challenge. Large, insecure, existing brownfield. There's a lot of that out there. And then the greenfield is, huge and growing at at an extremely rapid pace. And then, a lot of remote low bandwidth scenarios as well that complicate all this. And so all of these pretty much are the challenges that we face. And the way we think about this is, let's start with what we can do. So that passive network solutions, like Defender for IoT, is one of the first key investments, and we're continuing to look down that range. Building new secure devices is something we want to get going so that we can stem the pain so that we don't have more insecure devices shipping. And then we're looking at, and we've got a use case a little bit later, how do we retrofit some of the modern security to the brownfield? And usually we have to couple this with a business advantage and make it something that's advantageous to the business, not just simply doing it for security's sake. And we're open to more ideas, but these are the ways that we're investing today. Love to work with you, get your ideas. Feel free to throw them in the Q&A. We're always looking for what are the ways that we can address these constraints, because this is a problem that we have to solve, not a problem that would be nice to solve. So we do need all the best ideas in there, and then work with you all to scale it out and help our customers succeed. So how does OT fit into Zero Trust? We see this question come up on occasion, and so we wanted to kind of clarify how we think about that. This is Microsoft's Zero Trust Rapid Modernization Plan, or RAMP, and this outlines the different initiatives that we would want organizations to take around the user access productivity world, modernizing SecOps or SOC, OT and IoT, and then data center and DevOps, which are each their unique challenge. But we wanted to highlight that that is one of the main initiatives here. We see Zero Trust, and as we see it at Microsoft, it is the application of key principles: assume breach or assume compromise, least privilege, apply least privilege, and explicitly verify, so explicitly validate trust. Those principles apply extremely well to OT and IoT. The challenge is you have to apply them within the constraints of old, crusty, hard to support devices and limited networks, etc. So you can still apply those principles in that space, and so we see that OT and IoT security as part and parcel of Zero Trust initiatives all up. Now, how does this actually fit when you kind of peel it back and say, okay, let's take a look at this through a Zero Trust transformation? This is a network lens, and then we'll touch on devices after this. From a network lens, most organizations very frequently had everything on a flat network. Now, you might have to go back 10, 15, 20 years before they actually put a firewall between OT and IT. Sometimes there isn't even a firewall today. So it really depends, but most organizations started with one flat network. We have this Ethernet IP thing, and so we're going to connect everything up together until we realize it's a bad idea. So first thing that happens as part of the Zero Trust transformation, or one of the first priorities we typically see most organizations take, tends to be in the front of house, not so much in the back-end data centers, but much more in the end user devices that people use, their laptops, etc., mobile phones. And essentially those are, moving on a course to not be part of that corporate environment. COVID and the lockdowns for the pandemic accelerated this significantly. And so a lot of people like myself, I used to have 50 to 75% travel. Now I'm sitting at 0% travel, and I'm kind of happy about it. I like spending time with my kids. But this is one of the first effects of Zero Trust, which was accelerated by the pandemic. And so those devices get access sometimes to a network, but more often to the resources themselves based on, do I trust you or not? Something you can do with a modern Windows 10, Windows 11 device, Apple devices, Androids, etc. You can do a lot of that trust validation, and then you shall or shall not be able to access things. So that's kind of how that is shifting on the network lens. Unmanaged devices, we tend in our architecture and recommendation to want to run those through like a remote RDP for remote access, or Azure Virtual Desktop, Windows 365 type of thing, so that we have full scope EDR visibility to those hosts and endpoints. So that's just a part of the architecture. Now, giving access to these things, we tend to want to publish these applications through something Azure AD App Proxy that gives us all that zero trust validation goodness, even on old crusty applications, which could include interacting with your OT IoT environment. And then falling back on VPN. We don't like VPN in that. So continuing on, because we got to get to the OT relevant pieces. Wrote this for a different story, but I wanted to connect and highlight how these connect together. Then we need to look at, and there's another half of the Zero Trust piece, which is more traditional network segmentation or macro segmentation type of view, which is where you take these different resources and you cut them off from the corporate network. And the reasons for that generally fall into 2 or 3 categories. So low impact IoT, and sometimes OT, printers, VoIP phones, those kind of devices are going to be in a separate cordoned off network. High impact IoT and OT that could cause life safety impact. Everything from air conditioners to elevators to welding machines and blast furnaces. These kind of things need to be in their own network that's separate off, because they're often also very difficult to maintain and old. And then sometimes there are cases and causes for having a business cordoning off and separating into a segment around things like, for example, at Microsoft, some of our Xbox and game development is completely separated off. And there's, a number of other business cases, and pharmaceuticals do very sensitive research, kind of like unpatented trade secrets and whatnot, on very isolated, tiny little environments. So there are reasons to do it from a business standpoint as well. These are expensive to maintain because you have to do them right, you have to maintain them. So they tend to be, we recommend there a short number of things. And one of the key things about this, kind of keying into that, is we have noticed this firewall and forget type of pattern, anti-pattern actually, that is really counterproductive, where people put that firewall in there and then they don't really have anything to make sure that it's audited, to do pen tests on it, to make sure that that boundary is in fact as strong as it was. And of course, to account for the exceptions. There are always exceptions of when you actually do need to access that, and then go ahead and make sure that there's a secure and easy process to do that. That tends to fall through the cracks. And the way that we look at this is through the lens of people, process, and technology. Obviously, you need to block and filter traffic. That's kind of the minimum first part. You also need to detect threats in this environment, which is where Azure Defender for IoT comes in. And then anything that bridges or allows transit or connection between those two environments, whether it's a temporary laptop that floats back and forth, or it's a permanent engineering workstation that allows you to control processes or monitor them, you do need to make sure that that is hardened, using zero trust principles and all the other elements as well. process is, of course, making sure you can accommodate that all the security processes that you would expect are there, but also securing those business processes, technical procedures that do interact with that environment. And people, you've got to train people. If they don't know how you secure the OT environment and how they're supposed to use it, they're going to break the rules out of sheer ignorance. So it's really important to have that people element as well, so people are very familiar with what their job is to do in it, and if they need to use the system, okay, this is the process you use. So we really view that as sort of a long-term lifetime commitment. So shifting into devices, we've been heavily talking about OT, ICS, and industrial IoT. So let's just talk about the whole spectrum of devices. So these are sort of the first ones here. These are focused heavily on monitoring and controlling physical processes, actual machines that change things, sometimes some sensors in the environment, but generally tend to have a high life safety sort of impact, and that's their purpose in life, is their computers to control something physical. The other end of the spectrum, we are putting consumer IoT, by the way, out of scope for this, because there are reasons why you would want to care about that, especially if you sell and maintain that as a company. But we're focusing more on the sort of company-owned and controlled devices. So the human processes range all the way from your standard IT endpoints that, Windows devices, Macs, Linux, you name it, into business IoT, so your voting, ATMs, point of sale, etc., that are very heavily associated with the IT technology, but adapted to a very specific use case very frequently. Pretty much almost all organizations have some form of network devices. And then you have this sort of in-between general purpose IoT, your cameras, VoIP phones, smart TVs, etc. There's things that may be sitting on the network that are not specific to you, not customized by you. They are general purpose, but they are corporate controlled in your environment. And so we have all these different flavors of types of devices with a little bit of indicators on, whether it shows up in most industries or just the physical sort of industries. And when we think about securing these, the first thing that we focus on is starting with the life safety impact. That is the number one thing to think about, is making sure we're protecting that. Now, does that mean that's the easiest thing and the only thing you have to do? No, you have to look at securing this end to end. But we do generally recommend organizations start by focusing on that. And then, of course, you always do the most important stuff and the easiest stuff first. Sometimes that's the same, sometimes it's not the same. So Microsoft's investments thus far. We showed you Azure Defender for IoT, that's our OT network sensor. And we also have the ability to do the micro agent for devices that you control and can install an agent on that doesn't violate regulations and has sufficient processor and RAM, etc. on these devices. And so that allows us to cover the OT ICS as well as industrial IoT. And then the micro agent also gets us into business IoT, particularly for the stuff that was customized by you, where you have change control and the ability to test, etc., etc. And so IT endpoints, we have our EDR coverage with Microsoft Defender for Endpoint there that addresses that fully. And then as Matt showed, we have inventory enrichment and some discovery that also extends us into some of that middle ground of the general purpose IoT and network devices. And so this is where I'm going to speak very carefully and use words very precisely. I don't have anything specific to add at this point in time, but I can tell you that middle area, the light green area, is a very heavy focus for us, and it is a very interesting place, and we do have some large Microsoft events like Ignite that are coming up, and I encourage you to stay tuned very closely because you may see something there that is a very interesting and very relevant to this topic. I'm not able to make any specific announcements at this time, but I do encourage you to tune in very closely in that early November event timeframe as we are actively investing in these areas. I don't know if the announcements will actually 100% make it out in that timeframe, and I'm not authorized to share even if there was such an announcement, but exciting stuff to come. So I wish I could say more, but that's all I can say at this point in time. So the other thing I wanted to highlight here, as we kind of shift to more of a greenfield frame, and how do we think about that greenfield space? Because we've been talking mostly brownfield, and how do we secure what we already have? The way that we think about securing a device so it's actually sustainably securable and secured is something called the 7 properties of highly secured devices. And there's an AKMS where you can read a lot more and get a lot more details. This came from a Microsoft research project that took a look at, okay, answer the question of how do you actually secure a device in a sustainable way that actually stays good, where the assurances work over time. And so learning from some of our Surface investments, a lot of our Xbox investments, because there is a lot of money in tampering with and cheating and whatnot in the gaming space. So we've done a lot of work in that space, and then of course others have also done some research as well, integrated that all together and came up with these. And these are the 7 properties of highly secure devices. It's not principles. There was a reason for that, because we wanted to have a measurable property that could actually be validated against, not just a general principle to follow and guide. And so there's a very specific reasoning for the naming of it as 7 properties. And hardware root of trust, you need to have that. If you don't have that, someone can come underneath the software and undermine it. Defense in depth design, a small trusted computing base. Let me just animate these guys in. And so you need to have a very minimal attack surface for that root of trust that you have. Dynamic compartments so that you can actually split up different functions and have, within the architecture, the ability to protect some components against others in the system. Very zero trust like in that fashion. Passwordless authentication, which really builds on multi-factor authentication. Error reporting, anomaly detection, so you can actually see what's happening to it over time, essentially monitoring. And then that renewable security, essentially patch and keep things up to date. So when we look at how do you actually make these real in an architecture, they actually took that research group and a number of other folks and moved those into Azure. And those folks then built Azure Sphere based on that experience and that research. And so the way we look at success in this is, you need to have chips that are secure, right? You've got to have those designs. You got to have an OS that is secured and maintained. You've got to have a cloud service that monitors it for anomalies and threats and vulnerabilities. Then you got to have the updates to actually fix it as it goes over the life cycle of that piece. That blue bar across the bottom is critical, because if that works for 3 years, wonderful, we're going to operate it for 20. That doesn't work. So you've got to have lifetimes for it, which led to the way we built Azure Sphere, which is that end-to-end approach with the Azure Sphere certified chip designs. The operating system itself, actually it's got Linux kernel in it. It's not really Linux OS, it's more of a Linux kernel because it is so small and compact. The security service on Azure that actually keeps it secure, monitors, etc., as well as the updates for 10 years or more is the time frame for these devices for the manufacturers. So we're looking at 10 years of support is generally the minimum there. And so that's how we built that. And then there's a case study, because that's great for net new devices, right? But ultimately, what about if we want to now do this to an existing device? So here's a case study that's real, it's out there, it's in production, it's probably in your neighborhood, where Azure Sphere was applied in what we call a Guardian module architecture. And the idea is Starbucks had the same machine in every store, and they got tired of having to send out a truck every time the machine stopped working. And sometimes the machine stopped working for legitimate reasons, it broke. But a lot of times the machine stopped working because the teenage employees or 20-something employees didn't know or had forgotten to change out the coffee grind thingy in the back, the little container that in the back. And so it needed just routine maintenance, but they weren't connected to the network for security reasons. So they needed a way to securely manage and monitor these things so they could stop paying to roll trucks out to tell these young employees how to fix something. And of course, they wanted to do more things as well, like downloading the recipes and all those kind of things. And so what Starbucks did was they used Azure Sphere Guardian modules. So it plugged into the machine and then into the network and it did the security thing in between the two of those, and it also did the IoT streams of data and control and all those kind of things in a very, very highly secure way using those Azure Sphere chips. Now, this worked really, really well for Starbucks, worked perfectly for Starbucks because they had exactly one type of machine, if I recall correctly. So they didn't have to deal with hundreds or sometimes even thousands of different machines in a given plant or factory or oil refinery or what have you. So there is an economy of scale challenge here because you can't write that app or put that code onto those Guardian modules for 1,000 different things just to handle one production line. That's why we're really looking into and investigating deep into the partner space because we want to work with OEMs and with all the different providers so we can get the economies of scale. As hey, we shipped 100,000 of these, they happen to be 10,000 different customers, but that scale now makes sense to write that app and then use it as a value add. So that's kind of the direction that we're looking here, and we think there's a lot of opportunity in this space to help with that greenfield problem. Still very early in this journey, but we wanted to share that so you had some context of our thinking. So bringing it back, we want to help connect OT and IT security. We want to get that mindset shifted that, hey, firewall and forget is enough. And we want to go and address these constraints and apply creative solutions, work with partners, work with the ecosystem to help solve a lot of these problems. So with that, that has been the vision and futures of OT and IoT security. And I think I am about out of time. So thank you very much.